Hi, we want to know how to design and size our solar power system. And for today, we're going to learn how to size our battery and our solar panel. So number one, let's start with battery. In order to know the size of our battery bank, we have to consider the number of loads that we're going to drive. So for example, let's say we're going to drive a 55 watts TV for 6 hours and let's say again two 9 watts bulbs for 8 hours, and again we want to drive a 65 watts laptop for let's say 2 hours, maybe want to do our research, and a 250 watts mini fridge maybe for 4 hours to cool our drinks, and a 5 watts phone charger, we want to charge our phone for 2 hours. So what we do, we just multiply the number of watts and hours. So 55 watts times 6, we get 330 watt hours, and 18 watts for the bulbs times 8 hours, we're gonna get 144 watt hours. Then 65 watts times 3 hours, get 195 watt hours. Then 250 watts for the fridge times 4 hours, you're going to get 100 watt hours, and so on for the phone. Then what we do, we add them all. So if we add all this together, we get 1679 watt hour for the battery. But remember, we need backup. Maybe some days are cloudy, and so we're going to multiply this by 3 days of backup, which is 679 watt hours times 3, and we get 5037 watt hours for the battery. And if we convert this to ampere hours, we're gonna divide by 12 because the battery is 12 volts, and 5037, if we divide by 12, we get 419.7 ampere hours for the battery. But remember, the battery we want to now, for any battery, we need to consider 50% of discharge in order to preserve or enhance its life or longevity. So we're going to multiply the original ampere hours by 2, and we'll get the 839.5 ampere hours. That is the original size of the battery that we'll use. And for solar arrays and the solar panel that we're going to use to charge our battery, it's simple. We're just going to take the number of the size of our battery in watt hours, then we divide by the sun hours that we experience in our day. Here in Kenya, we are below the equator, so we experience 6 hours a day. So that is what we're going to multiply to divide by the size of our battery. So size of our battery bank in watt hours divided by size of the sun hours in a day. That is the total. The answer we get is the size of the panel that is going to be used to charge our battery, which in this case is 5037 watt hours divided by 6 hours, and we get 839.5 watts. And we want to bump this to 900 watts because solar modules are cheap, so it's okay. Please stay tuned for more videos. I'm going to show you how to size the inverter and